This is AP problem number 12. For A, it said to draw the Lewis dot diagrams for CO2 and CO3 2-. For CO2, it shows a double bond for C for both O's and two pairs of pairs of electrons for both O's. And for CO3 2-, it has brackets and then the representation of the charge of 2- around it, and it is like this with two single bonds and one double bond and multiple pairs of valence electron pairs. For B, it is to explain and consider the bond lengths. So since CO2, between the CO bonds are double bonds, which means it's weaker in bond length, considering a single bond is the strongest. So since the CO3 2- holds two single bonds, which means it is the greatest, as shown here and here. For the second part, it was to draw the CF4 Lewis dot diagram and SF4. For CF4, it's a tetrahedral and it has single bonds for all F's, considering that's the highest, with 6 valence electrons for each F. For SF4, it is the similar shape but with one lone pair and 6 valence electrons for each F. For B, it is to explain why CF4 is nonpolar and why SF4 is polar. So CF4 is a tetrahedral, which means that its bond dipoles cancel out, which leads to a nonpolar molecule. And as you can see, when you have a tetrahedral, it is nonpolar. It has 4 bonded pairs, as shown here, and it has 0 lone pairs, which you can tell by the diagram. And SF4 is a representation of a trigonal bipyramidal with lone pairs, and its dipoles do not cancel out, which results in it being polar. So as you can see here, there is a couple one lone pair, and so that means it's trigonal bipyramidal, which is here, which means that it's polar. There's 3 bonded pairs and 1 lone pair, and you can see the lone pair here. And that is all for AP problem number 12.